you have a fever, don't come to school. So if you feel like crap, check if you have a fever. Casey, what's it mean to distribute?
To like spread out and give out like other places.
Yes, spread out, give out to like everybody. So like if I brought in a bag of cookies and I said, I'm going to distribute these cookies to everyone on that side of the room. Would that be fair? No. So when I bring in my bag of cookies, only they get it, since you guys just said that was fair. No. So, what we're trying to make the point of is when you distribute, Flynn, can you put it away, please? When you distribute, you give to all or to every. So when we have a value on the outside of a parentheses, that right up against the parentheses is telling you to multiply. So you might want to, I advise you to make a note. This, actually do it on the bottom. This right here tells me to multiply when a number is right up against a parentheses. Anytime a number is right against a parentheses. By the way, Miss Benson, you might want this. Then what you always need to write. If you guys were here on time, you'd have notes and we'd stop wasting time. You've only been in class half of a block. You shouldn't really need to go to the bathroom yet. Always you need to draw arrows from the value on the outside of the parentheses to every term inside the parentheses. Notice I didn't say every piece, because it doesn't go we'll get there. But when there's if this was 4x instead of just x, it just goes to the 4x. It doesn't go to the 4 and the x. It doesn't separate. It goes to every term in the parentheses. So 3 times x gives me 3x. 3 times 2 gives me 6. So how this really looks when you break it all up, shown right over here, give you another example of this. So we have our arrows showing. So the 2 is going to multiply by the negative 3y and the 5. So 2 times the negative 3y, negative 2 times the negative 3y, and negative 2 times the 5. I do the multiplication. Notice the negative 2 times the negative 3, the y, how I say it, just comes along for the ride. It just hangs on. It's like if you had your little brother hanging onto the roof rack of your car while you're trying to drive away, and you're like, get off of there. He just won't fall off. No one? Okay. Guess that's just me. Yeah, if you're not paying attention, we're moving on. So we do negative 2 times negative 3 gives me a positive 6, and the y just keeps kind of hanging on. I can't combine these two terms. Why? What is it called when I can combine two terms? We say those are blank terms. Something special about them that lets me add them or subtract them. Bella? They are like terms. So these are not like terms. They can't be combined. Any questions on that? Because I don't know what y is. I can't combine these until I know the quantity of y. Because if y is 10, then this is 60 minus 10. But if y is 2, it's only 12 minus 10. So knowing what y is has to happen first. What? Here? You can? Or are you asking why can't we add those? Because this is a variable term and this is a constant term. And they can't work together. Like, we don't know what this is, so I can't add or subtract with it. If I had another constant term, like say I had plus 5, that I could add because they're both constant terms. But this being a variable term locks me down. So, when we see a number right against the parentheses, the first thing to do is draw the arrows. So with all of these down here, just go draw the arrows. We'll solve them in a second. Just go draw your arrows. So we want some arrows here, from A to the 2 and A to the B. And some arrows here. And we want some arrows down here. So, for my first one there, we show A distributing to the 2 and the B. So, Joe, this really turns into, if you want to like talk about each multiplication by itself, this is going to be A, the first arrow shows me, A times 2. Then I grab the symbol from in between them and just place it between them. And then we have, A times B. Because each arrow is showing me a multiplication. So then, when I clean this up, I put my number in front of the variable, which is called our coefficient. There's a lot of this vocab that some of you, if you're not focused, you're just like writing what we write. If you're not listening, you're going to miss a lot of stuff. We put the coefficient in front because it's nicer. And then A times B, I can just write as AB. I don't even have to put the multiplication in between. I do have to keep that plus between them. So I get 2A plus AB. Any questions? I would probably write in there, like I'd just fix it and just show it. And now if you did it on every single one, I'd probably talk with you about it because it's just not accurate. Like, it's not that it's wrong, just to be all the way simplified, you put the multiplier in front of the variable because we call it a coefficient. So, for my green arrowed expression down here, am I blind, missing Maylee? Oh, Maylee. Hi. So, my 5 distributes. Each arrow shows me multiplication. So this becomes 5, what? The first arrow. Huh? Yeah, the first arrow is just 5 times 1. You bring your minus. And my second arrow shows me 5 times. Each arrow is multiplication. So 5 times 4c. So that's, when we draw the arrows, we're notating what's going to connect through multiplication. So then I simplify. 5 times 1 is 5. 5 times 4, yeah, so this is minus 20c. Because we do the multiplication with the numbers, and the variable just comes along with it. What do you mean? Add what? You're right. Did I? This is multiplication. So if I have 4 carrots in a bag, and I have 5 of those bags, how many carrots do I have? 20. If I have 4 carrots in a bag, 3 bananas in a bag, and 4 apples in a bag, can I make banana apple carrots? No. That's what we're talking about. Are they like value? I can have 5 bags of something. I cannot add 5 bananas with 4 carrots. And like, do you see where the difference comes in? They can't be added or subtracted. This is multiplication. You can multiply or divide them all you want. We are not doing, I think what might be throwing up, we're not doing this. The subtraction doesn't ever get done. We're stuck right here. We can't do this subtraction. We're done.
Okay, so you can multiply, but you can't add or subtract.
Correct.
Okay, got it.
Other questions? Okay, the last one here will turn into, Abby?
When it turns to negative 2/10 times 7x.
Yep.
Minus negative 2/10
So I'm actually, because I have minus the negative, I'm going to put that in parentheses.
times 3/10.
Perfect. Questions on how we did that distribution? We did the negative 2x to the 7, or negative 2/10 to the 7x, and then the negative 2/10 to the 3/10. This we're using as a minus, so it comes over as a minus. Then I clean it up. Forget about the decimal for a second. What's 7 times 2? 14. Bring the decimal back in. 1.4, but it's negative because we have the negative in front. Then minus, or sorry, make sure you bring your x along. I almost forgot to bring it. What was the murmur? Are there questions? Okay, then minus a negative. What's minus a negative? Plus a positive. Then this is where people screw up. Who's bold and confident and thinks they know what 2/10 times 3/10 is? Be careful. Think about the fractions. Abby, do you think without a calculator? Did you use a calculator? Thank you very much.
No.
Okay, 2/10 times 3/10.
Wouldn't it be 6?
Yeah. 2/10 times 3/10. When we multiply straight across the top, straight across the bottom, we get 600ths. So this becomes 0.06. We cannot combine these. We are stuck. We are done. Any questions on expanding those expressions? We're applying our distributive property. Now, we can't solve them because they're not equations. If I knew that this was equal to 17 or equal to something else, some other quantity, then I could solve it. But I don't know what it's equal to right now. So guys, this is where people get confused between expressions and equations. Chapter 7, we're pretty much just working with expressions. So when you look at like this is equal to that is equal to this, this is not an equation. These are equivalent expressions because every expression is equal to each other. All the blues are equal, then all the greens are equal, all the reds are equal. They're not equal to, like red's not equal to green or anything like that. If I knew that this was like equal to 24, then I could work to solve it. But we don't. So we can't. Questions? All right, try the got it. Which one shows the sum or the difference that is the same as the given expression? First thing we really need to do, figure out what is this expression when I evaluate it. Izzy, when I look at negative times a negative, it's the first thing in your head. Negative times a negative will make positive. So immediately think of my values going to be positive. Then a fifth of 5. What's a fifth of 5? 1, and then the m has to come along for the ride. plus, what's a negative times a positive? A negative, and then a fifth of 10? 2. Then we clean this up and take away what we don't need to write. What's this become when we clean it up? Okay. Ooh, it does become the second one. So this just becomes m minus 2 when we clean it up. So we know the second one works. So then would negative m plus 2 also work if I just flip the signs around? No. This m has a positive value. Period. You cannot change that. This 2 is being subtracted or is negative. You can't change that. So option 3, write out. What about option 1? So let's check. What's negative 1/5 times 10? Well, negative times positive, a fifth of 10, we get negative 2. Negative 1/5 times 5m, or I could treat it as negative times negative if I treat this as a negative instead of a minus, but I'm going to treat it as a minus first. Negative times positive gives me negative. A fifth of 5 gives me 1. The m comes along. This ends up negative 2 plus m. Is that the same? Do I have a positive m? Do I have a minus 2 or a negative 2? Yeah. This is the same. These are equivalent. This works. All this shows, and I would like you to write this, is the commutative property. To commute means to move or to travel. All we did there was move our numbers around. We put the minus 2 first, the positive m last. Questions? All right. So, which of these expressions, when we flip to the back, can actually be expanded? Which of those could you distribute and multiply and expand out the expression? Julia, what do you think? We'll call this A and B. Like, if we read through this. Ooh, and here's the other thing. When we have values, and I forget if I said this in this class because I'm teaching similar stuff in the earlier class, we would say the quantity 5 minus x times the every time you open a new parentheses, you say the quantity. So this, we'd say the quantity 5 minus y, or 5 minus x. Then once it closes, you have to say another, like operation or whatever. So if we look at A versus B, which one could be distributed, multiplied, expanded? So if we look here, let's read this. Quantity 5 minus x, then what happens? Well, what would this symbol then be? Like, if we did quantity 5 minus x.
Oh, I thought, what was the negative sign? Is it a negative sign or a subtraction?
Well, as I'm reading, could I say quantity 5 minus x negative y? And to do times negative y, we would need the added parentheses. So A can be expanded, B cannot. This, please make a little divide, this is going to multiply by negative y. This is going to subtract the y. So that's the difference. This is going to be quantity multiplied by negative y. This is quantity minus y. questions on why they are different. If you want to expand it, you got to choose the first one. This can't be expanded. The only thing I could do to this is rewrite it 5 minus x minus y. That's all it comes into. This would actually become negative 5y plus xy. If you care to know what it becomes, that's what it actually becomes. So, my buddy Randy's an architect, and a lot of times they have modification projects where they come in, people say, I want to make this bigger. And a lot of times, this is exactly how it goes. How much bigger? Well, we don't know. How big can we make it? Well, how big do you want it? We don't know. How big? And they go back and forth, and it's kind of like, well, draw me up a plan, and then we can figure out how big we want it. And that makes my buddy like throw his hands up in the air. Draw me a plan, and then we can figure it out. So sometimes architects will draw plans not knowing the exact dimensions they're talking about. And when we don't know something, we use a variable. So this patio, 3.7 meters by 4.5 meters. Which, by the way, meters are a little over a yard. So when you think about 3.7 meters, we're talking like this times 3.7. 4.5, this times 4.5. So they want to expand it by x meters, and we want to find the area. So up here, this 3.7, we need a label. That's the width of the deck. So put a little W above that. This 4.5 plus x. What would the 4.5 plus x be? Andrew?
The length.
Yeah, the new length, right? Because the old length was just 4.5, and then I'm going to add on my section of x. So this is my new length. So what do we get when we have width times length? What does that give us? What? No, that's our third dimension. Gives us the area. So this is equal to the area. So now let's actually distribute these values. So we have 3.7 times 4.5 plus x. Draw your arrows. Then write out what multiplication happens. Bella, what multiplication happens here?
3.7 times 4.
What operation between them? Yep. And then? Ooh, the x gets multiplied also times x. And then we can clean it up a little bit. Yeah, we'll need a calculator for this. Anyone got one? Ooh, Julie's got one. 3.7 times 4.5. What is it?
16.65.
16.65?
Yeah.
So again, this comes back to, I can't add these. I can't find the area until we know how much they want to expand it by. Once we know how much they want to expand it by, then we're good. So people would use this to say, well, if this is my new area and I have a certain cost of tile or a certain cost of whatever, they might figure out how much they want to pay and determine the area based off a certain cost. Any questions at this point? We got to make sure we draw the arrows first so that we know that we have to distribute the multiplication and do it to each term inside. So, for your birthday party, and we're going to have you solve this on your own, you decide that you're going to order 2 cupcakes per person because you're such a nice friend. And then, because you want to have some extras, you order 5 extras. So, I need you to list what do the terms in the expression represent, and then figure out what the cost would be after you distribute. So try to simplify down your cost as much as possible.
They are.
I'm not saying you can't, I'm saying in my class, you're not allowed to. We have a better alternative. Not when I provide it. The phone's a whole lot more expensive than the iPhone. I think you're arguing the same thing. I'll be right back. We have moved more quickly than I anticipated, which is a very good thing. Because if we move through these things quickly, because we can have a work day. So, when we start looking at what these pieces parts mean, what does that 2.25 represent? Pass them back, please, gents. Oh, of course I'm one short. I got it. Don't worry, CJ. Got one special for you. Jack. What does that 2.25 represent in that situation? No. Because you had plenty of time. What does the 2.25 represent? If you read 2 sentences, you should have seen this. Thank you. You're allowed to take some time to think, but do not just immediately pass because you sat there and did nothing while I was out of the room. So 2.25 is your cost. So we could label right here, this is the cost of each. So I would put each cost or something like that. The 2x, Kylie, what's that represent? Yeah, your 2 cupcakes for each guest. So then your 5, Atticus. What's the 5? Yeah, the extra that we ordered. So when I expand this out, CJ, can you walk me through my process? This becomes 2.25. Well, what's it multiply to first? Like, what's that first arrow tell me to multiply with? Yeah, times the 2x. Then I grab my operation from between them, and then what do I have? Yeah, exactly. Then, yeah, 4.5x plus 11.25. So this is your cost for your guests' cupcakes once you know how many guests. And the 11.25 is the extra charge, regardless, because you know you're buying 5 extra. So now, what if I tell you you're inviting 10 guests? So if x equals 10, then all we do, anyone know? If x is 10, if we now invite 10 guests.
4.5 times 10.
Yeah, exactly. And the answer comes out to be 56.25. Well, really, this becomes 45. Add 11 gets 56 plus the quarter. Good quick math. So this comes into if we know the variable. But with your expressions like on your homework and stuff, you will not know the variable. Any questions, comments, concerns? We have 10 minutes, which is a great amount of time to go ahead and start 7-2 so we can get a head start for when these lessons get to the complicated point. It's up there. I won't change that. Huh? I passed up 7-3. Okay, let's start 7-3. So that's funny. I printed 7-2 for some of you. Will one of you 5 ladies run and grab this off the printer? I'm going to print 5 copies of this. All right, so factoring. And actually, when I go tweak your homework, when you guys leave class, I may just combine 7-1 and 7-2. So do you guys have a preference whether the homeworks are split or combined?
Split.
Because they're smaller and they're shorter.
Yeah.
Okay.
Just give us 7-3 though.
They're getting 7-2 off the printer. I also have them over there, but we just had this conversation. I know. That's why I'm slightly frustrated. I'm having to explain this. Yeah, just be cool. So, factoring is exactly the opposite of expanding. So, the first thing I need you to put on your notes is an arrow going this way and an arrow going that way. This is a cyclical process. If you factor, then you can expand. Then you can factor, then you can expand. Were you out of the room, Grace?
Yeah.
You print another extra. Oh, never mind. Those the 5 of you guys, because you were the only one. Hey, hole punch them right there before you hand them out. So check this out. To factor something, you're looking for the greatest common factor. Now, what is a factor? Like people say, like, oh, your dad factored into your hair, or your mom factored into your personality. Like, yeah, a part of something, that we can like take out or look at independently. So when we go to factor 10x and 45, these are not like terms. I cannot combine them. But they do have something in common. Both 10 and 45 could be divided by the same thing. Yeah, they could both be divided by 5. So when we divide them both by that same 5, these come together and make the coefficient of a binomial. So when we divide out by the GCF, that GCF goes in front. Then we look at, well, what is, and this is when if you have highlighters, your life will be a lot easier. If you don't, I've told you till I'm blue in the face, get highlighters. 10x divided by 5 becomes, go ahead and just run this problem, Justin.
So it'll be 2x plus
Thank you again.
9.
9. These two expressions are identical. They look different, but they are identical. So, do we have questions on the fact that now, if I distribute, watch how dumb this can actually become. If I now distribute, this becomes 5 times 2x plus 5 times 9, which gives you 10x plus 45. This process is cyclical. The one step undoes the other step. Factoring is the reverse of expanding or of distributing. Any questions on how we factor? I'm going to show you a couple more examples. Okay, so look down here at this expansion, this distributive property shown out. The -6 is going to multiply by both terms here. So we have -6 will multiply by 3x, -6 will multiply by -4. We go through the whole process and we get to 18x plus 24. If I ask you in this process, what is the GCF between these terms? It's shown to you. It's like right in front of your face. It's what? It is, yeah, it's your greatest common factor, but in this situation where we started right here, what was your GCF? Like they already had it pulled out for you. Yeah, the -6. So -6 would now be your GCF in this expression. So if we wanted to factor this, we would just divide by -6 and divide by -6. Now the reason they pull out the -6, we like to end up with a positive variable value. So after they factor, we get to here and my variable is now positive. We like the variable value to be positive. Either way would technically be correct. You could just factor out a +6 if you wanted, but the -6 makes it a little bit easier for my variable. So, here, we want to factor 15x plus 21. We got to identify what 15 and 21, because we don't care about the x, it's just going to come along for the ride, which value they could both be divided by. Lily, what could 15 and 21 both divide by? 3. So, we show up here that this can divide by 3 and this can divide by 3. So another way to show this process is come over here, show that we divide by 3, divide by 3. So now this shows my 15x and this shows my 21. Practice. I'm serious. Same thing with like, now I'm not going to be able to do it. Like that one music symbol that's like, I used to be able to draw it because I had practice. Yeah, thank you. I was at a loss for words. And the ampersand.
Ampersand.
That's weird too. Yeah, the and symbol. Loop it up and swing back around. I can't. The music symbol is hard. It's like something like that. Something weird. I think I might be backwards. I don't know all the weird clefs. There's like 17 awkward clefs. So, the greatest common factor, guys, what goes, hey, bring it back. What can multiply or divide out of, can multiply to go into or divide to come out of, that goes in front of your parentheses, and the values you're left over with goes in your parentheses. Any questions on any of this? We good with factoring? Because now we're stepping forward into combining like terms. You guys should hopefully, it is not your fault if you don't know this, but in 6th grade, you should have talked about what makes a like term.
Oh yeah, we did.
If I have, so Abby, can you try to explain it then?
So for like terms, if you see two numbers but they both have the same variable, like if you see in an expression.
Yeah, it is hard to say. In
like
an expression.
18a plus 5b plus 58.
So like 18 apples, 5 dentists, and what else did you say?
I think I said,
So another A.
Another A, then more apples.
yeah. So what you would do is you would have both of the same. So you would have 2 apples and you would add them.
Yeah, so you take your groups of apples, and you can put those together, but can you add your dentists in with
No.
it? No. So where we're going to pick up tomorrow is talking about why we can or cannot combine certain terms. Thank you guys very much. Give me a little bit of time to fix 7-1. Give it a shot. Come back with questions.